Hello class, so we're going to take a look at limits at infinity, and these limits at infinity are going to help us find out whether or not we have a horizontal asymptote. So just to clarify, HA stands for horizontal asymptote. So when we're looking for these horizontal asymptotes, we're going to take a look at limits as I'm approaching infinity or as I'm approaching negative infinity. So you have three different options. One of our answers could be infinity. So I'm going to have no horizontal asymptote and just keep increasing up to infinity. Or I can get negative infinity, just telling me that I can decrease towards infinity and not have a horizontal asymptote. Or I could get an actual asymptote that has a numerical value. So the other option is to have a horizontal asymptote with the equation y is equal to something. So we'll find out how to do that in this next section. Okay, so in order to do this, we're going to do the same process as before where we plug in our limit to see what happens. Now, since we have negative infinities and positive infinities, we're going to take a look at how this affects, how the numbers affect infinity, since some of the numbers are pretty irrelevant when we compare it to infinity. So let's take a look at this with the first example. I'm going to plug in a negative infinity, so I get negative infinity to the third minus 2 times negative infinity squared plus 3 over negative infinity squared plus 4 times infinity. So the number 3 is actually pretty irrelevant if I'm adding 3 to infinity because that would just give me infinity. At the same time, if I square an infinity right here, but I have a cube, the cube's going to get so much bigger than the square that this doesn't start to matter at all. As well as multiplying by a 4, that's not going to do much to what we have. So let's go ahead and take a look at what's left over. And if you notice, I have these two terms left over. So what we're going to really look at is which term has the highest exponent and compare those numbers. So if I were to rewrite this, I have negative infinity to the third power divided by a negative infinity squared. If you notice, these have the same base. Since they have the same base, I can cancel these powers, and if I have a 2 here, that's going to cancel out 2 up here. What I get left over is a negative infinity over a negative. A negative over a negative gives me a positive infinity. So the answer to this one is a positive infinity. Let's go ahead and take a look at the next problem and see what happens when I plug in a positive infinity. So we'll do the same thing, and I have infinity to the third. We said that these terms don't matter. And I have a negative infinity squared. So if you notice, 2 of these cancel, 1 of these cancel, and what we get on the top is a positive infinity, oops, I'm drawing my infinities wrong, divided by a negative. So our answer here will be a negative infinity. So like I said, we're going to take a look at the parts that have the biggest exponent, plug in our infinities, and see what happens. So let's take a look at the next problem. Right here, you notice I have square roots. So let's go ahead and square root some of these and see what happens. If you notice, inside the square root, this 5 doesn't really do anything for us, and underneath the denominator, or in the denominator, that negative 4 doesn't do much for us as well. So what we're going to do is plug in our negative infinity, square it, and then plug in our negative infinity down here. Well, negative infinity squared gives us a square root of infinity over 3 times negative infinity, right? And if you take a look at that, the square root of infinity is infinity, and so I get infinity over, I'm going to plot that negative from there. These cancel, and what I get left over is a 1 over a negative 3. So my horizontal asymptote is y is equal to negative 1/3 as x approaches negative infinity. Let's do the same thing with a positive infinity. I get infinity squared over 3 times infinity That's going to give me infinity over 3 infinity. These are going to cancel and I get 1/3. So here I get y is equal to 1 over 3. Perfect. Alright, so let's go ahead and take a look at the next problem. Once again, let's take a look at our powers. And if you notice, this term right here has a bigger power, and this term right here has a bigger power. So I'm going to get rid of this one and this 2 right here. I plug in an infinity and I get 4 infinity squared over negative 5 times infinity to the 3rd. That means 2 of these on the top cancel and 1 of these cancel. And if you notice, I have a 4 left over on the top. Negative 5 times infinity will probably remain an infinity. But here's the thing, if I have a 4 up here and a really large number in the bottom, the bigger and bigger my number gets, the more I approach 0. So here my horizontal asymptote is when y is equal to 0. Let's plug into this one right here, and we get 3 times negative infinity to the 4th, and we notice these are less than 4, so I don't need that. Down in the denominator, this is not needed because it has a square power. So I'm going to do negative 2 to the negative infinity to the 4th. These are exact, and so we know those cancel, and what's left over is a negative 3 over 2. So our horizontal asymptote here is y is equal to negative 3 over 2. Perfect. Okay, let's take a look at some of our fraction powers and see what happens when we do these. So, like we did before, we're going to take a look at which one has the bigger power. This one has a 4/7 and this one has a 1/2, so we know this is not going to be needed. And here we have a 1/3, which is about 0.333, and we have a 3/4, which is bigger than this, so we're going to plug into the 2 left over. And I get 4 times infinity to the 4 over 7 divided by negative infinity to the 3 over 4. So let's go ahead and find our common denominators and see what happens to this. And we get a common denominator of 28. So if this is 28 divided by 4, that gives me a 16 on the top. Over here, I get negative infinity to 28, gives me a 21. As we can see, the bigger exponent is at the bottom, so that means this one is getting a lot bigger faster. So because this is happening, this gets so much bigger than this one up here, we're gonna get say a number up top, and this approaches 0, so I get y is equal to 0. So like I said, we're comparing these right here. Since this one is larger, then we know our asymptote's approaching 0. Let's see what we can do for the next problem right here. It says I need to plug in a negative infinity. And if I plug in a negative infinity, you notice that we have this square root of x right here. Well, if I bypass everything and I plug in a negative infinity and a square root, what's the big problem here? Good, you have this negative sign, which we know is not possible. So even though I might be able to plug into these other values, because I have one piece that is undefined, this gives me a horizontal asymptote that does not exist. Alright, we have a couple more to go. Here is our next problem. And we're going to do the same thing, plug in our infinities and see what happens. If we notice in the top, our 5 is the bigger exponent. In the bottom, the 5 is also the bigger exponent. So I get negative infinity to the 5th over negative 4 times infinity to the 5th. These cancel, and the positives cancel, and I get a 1 over 4. So my horizontal asymptote is that y is equal to 1 over 4. Over here, let's take a look, because we have a trig function, and trig is a little different. So if I plug in infinity, and we're going to forget that right there, I get infinity squared. Our sine graph has a frequency, and if you recall, the highest this ever gets is 1. So even if I approach infinity, the highest sign of infinity will ever be is a positive 1. If I divide this by an infinity squared, we know that the bottom is increasing so much bigger than that 1 that this is going to approach 0. So we get y is equal to 0. Okay, so as you notice, this problem right here is slightly different, and we're going to have to multiply this out. So what we're going to do is we are going to pick one of these values and actually FOIL this out. So if I do the top, I get x cubed plus 3x squared minus 4x minus 12 divided by, and I'm going to do the parentheses first, and I get 12x minus 3x squared minus 8 minus 8 plus 2x. Right? And so we're going to distribute this x right here, and on the top it's going to stay the same, x cubed plus 3x squared minus 4x minus 12. Down here, I'm going to move everything over, so that gives me a negative 3x cubed. 12 plus 2 is 14, so plus 14x squared, and there's the minus 8. So like before, everything that's a value less than the highest degree does not matter over here. I'm going to plug in a negative infinity, so what I get is negative infinity cubed divided by negative 3 times negative infinity cubed. As you notice, these are going to cancel, and I'm going to get a 1 over negative 3. So my asymptote here is going to be, I'll write it right over here, y is equal to a negative 1 over 3. Okay, let's go ahead and plug in infinity up here. As you notice, these aren't going to matter too much, and I get negative 2 to the infinity over 2 to the infinity. These are going to cancel, and what we get left over is a negative 1. Okay, so let's do the same thing, but if you notice, we have a negative infinity here, so we're going to have to be careful. So let's see what happens when I plug in a negative infinity. Since my exponent is a negative infinity here, we know that that's actually rewritten as 2 over infinity over 5 plus 2 over infinity. And we know that 2 over infinity ends up to become 0. So in this problem, this does not matter. However, I have this left over, which tells me my asymptote has to be 3 over 5. Okay, we have a couple more to go. Same thing, let's take a look at our highest powers. We notice this doesn't count and this doesn't count, so what we do is negative 3 to the infinity to the 4th over 4 times infinity to the 3rd. 3 of these are going to cancel, and what you notice is I have an infinity on top, and I have that negative, so what we're going to get is a negative infinity here. Same thing, I'm going to cross that one off, cross this one off, and I'm going to plug in a negative infinity now, so I get negative 3, negative infinity to the 4th, all over 4 times negative infinity to the cube. 3 of these cancel, and you notice I have a negative and a negative, so this is going to give me a positive infinity. Over here, let's go ahead and plug in. We notice 2/3 is bigger, so I don't need that. And we also notice this is bigger, so I don't need that. So I get the cube root of infinity squared over negative 4 square root of infinity. It's going to give us an infinity. Next one, I'm going to plug in an infinity, and I get cosine of 1 over infinity. Well, 1 over infinity is actually 0, so the cosine of 0 is a positive 1. Over here, I plug in infinity to the 10th, that doesn't count, over e to the infinity. This is getting larger so much faster. So since that it gets larger so much faster, this is actually going to approach 0. And over here, we have to be careful since I have a negative infinity. So I have negative infinity to the 10th over e to the negative infinity. Negative powers can be moved up top, so I get negative infinity to the 10th times e to infinity. This will be positive, that will be infinity, and so this will be infinity. And there goes your unit on limits to infinity. We'll continue taking a look at this, and let's just make sure you take a look at the bookwork that is posted online. Thank you, ladies.